Let's take an example. I am on a bicycle. Here's my bicycle. And I'm sitting on a bicycle here. And I'm trying to get going. And I have a certain velocity. And I keep that velocity constant. That's the way most people would ride their bikes. Now, there is air drag, which is unavoidable. We discussed that. And the air drag acts like a force on me, F drag. And so somehow I, Walter Lewin, will have to come up with a force in this direction to overcome this drag so that the speed can be constant. Because if the net force is 0 on me, then of course I will have a constant velocity. No acceleration, no change in the velocity. How do I do that? Well, I push on the pedals. But the pedals push back on me. Action equals minus reaction. So that causes no net force on the bike at all. I push on the pedal, pedal pushes back on me, those two forces cancel. We call them internal forces. Now the pedals push on the chain, and the chain pushes on the wheel, and ultimately this wheel wants to start rotating in this direction because of my pedaling. And now here with the floor, with the road, there is friction. And so now the wheel pushes onto the road, and the road pushes back. Action equals minus reaction. And it is that force, which is really the friction, that is the force that Walter Lewin has to come up with in order to make sure that he can go with a constant speed. It's the friction that does it. You have to really think about it. It's remarkable. If there were no friction of that road, you couldn't cycle. I could do this and I would just stay still, right? There would never be any force here that would drive me in this direction. So you can't go. Of course, if you had a speed and you were sliding, then of course you would always maintain that speed.